All right, folks, so we're going to look at part 2 of our demo here, which is going to be using the other button, button B, to turn on one of the neopixels. Uh, that's one difference. We're going to use a neopixel instead of the built-in LED on pin 13. The other thing that's going to be different is I want to use this button as a toggle. So when I push it once, that LED will come on, and then when I push it a second time, it'll turn off. And then I push it again, it'll turn on, and again, it turns off. So it'll be like an on-off switch for that LED. And I'm going to add this to the code I was working on last time. So similarly, I'm going to sketch out what I want to do with comments. So I'm going to check if button B is pressed, and then if pressed, I want to toggle the LED, and then part of that will be turning the, I should say, neopixel on and turning the neopixel off. Similarly, we're going to need some more declarations up in our setup, right? So I'm going to say pin mode cplay right button input pull up, that's button B. Let's see here, the neopixel pin, I want that to be an output, but I don't remember off the top of my head what that what the library has as a name for that neopixel pin. So I'm going to look it up in the library itself, right? So this is a bit more of an advanced thing, but if you don't know the name of something or you can't remember, one thing to do is to look in the reference, right? So you can always like highlight a command in Arduino, and if you right click it and go to find in reference, it'll take you to a web browser and it will tell you all about how that works. It'll give you the parameters, like you need a pin number, the mode, it could be input, output, or input pull up. There'll be an example. So it's really, the reference is really helpful. And you can also find this on the arduino.cc website. But you'll notice like these things are part of that custom library from Adafruit. They're not in the Arduino reference, and there's not a quick way to get to the reference from here. We might go to see if there's some examples, right? So if we go to File, Examples, and then go down to Circuit Playground, let's see, there's something for the mouse, there's something for sensors, tack meter, some initial ones. Ah, here we go. Hello, NeoPixel. We could open this up and see what's there. And looking at this, it looks like we don't actually need to declare that pixel, that neopixel pin, as an output. That's interesting to me. But let's go with it. The one thing we do need to do, though, is begin the library. So instead of initializing a pin, we're gonna init the Circuit Playground Express library. Oops, I guess I didn't actually copy that command. Circuit playground dot begin. Okay. That will allow us to use the neopixels. So now, normally, you may notice that I'm avoiding using the library so far, and that is because I want you to be able to understand some of the fundamental stuff about how the Arduino platform works from a code perspective. But when you get to some advanced topics, obviously libraries are going to be helpful to you. So for the neopixels specifically, I'd be using a library one way or the other, whether I use neopixel library or circuit playground library. You need to use a library to run them. So that's why I'm using it here. Okay, so then let's look at our code for this. Check if button B is pressed. Let's do that the same way. I'm going to say if digital read C play right button. And I can use a shortcut here. I'm just going to leave that as the thing, digital read C play right button. That returns, that digital read C play right button returns a value that's 0 or 1, whether the voltage is high or low on that pin. And if I say if that, right, if the default case is this true or false? Is the statement in here true or false? And so if I say if digital read, it's saying, is it 1 or is it 0? So if it's 1, it's going to be true, and if it's 0, it's going to be false. So I don't really need the equals 1 for a simple expression like that. If that's true, then this is where it's going to get a little bit more interesting. I want to toggle my LED, right? So if the button is pressed, then I want to toggle the neopixel. To do that, I really need to be able to keep track of that neopixel state. And you can see here, I'm messing around with my spacing. Arduino is not as like persnickety about your spacing as Python is. However, it is nice to keep these tabs correctly indented, again, for legibility for other people to know what's going on, and for yourself when you come back to this a few days from now and are trying to make sense of it. So I need something to track my LED state, because I'm not just doing when the button's pushed, turn it on, when the button's not pushed, turn it off. So I want to track that state, so I'm going to use variable. I'm going to say int neo state, and I'm going to give it a default value of 0, which will be our off condition. So that's our variable for the state of our neopixel. And so I want to toggle that state, right? Okay, so then I'm going to have another if within my if. It's kind of like a double-decker taco. We've got an if within an if. So I'm going to say if neo state, and I'm going to make this just really clear here. If neo state is 1, that means the LED is on, and I want to turn it off. I guess I should do it the other way, right? If it's off, I want to turn it on. So if neo state equals 0, the LED is off, and I want to turn it on. So I'm going to say, then we're going to turn neopixel on, else here's where I want to turn the neopixel off, right? Because if it is not off, that means it's on, and I want to turn it off. And so part of each of that is going to be toggling my state, right? So if the neo state is 0, I'm going to turn the pixel on. Well, that means that neo state then is going to be 1. So I'm going to change neo state to be 1. And notice the difference here, right? Equals equals, I'm checking the state of it. I'm comparing something. Equals 1, I'm changing the value of neo state to 1. So then this would no longer be true. And similarly down here, I'm going to say, okay, well, if I get to here, that means neo state is 1. That does not equal 0, so then I'm going to go to else. But now I want to make it equal to 0, so I'm flipping it. So I'm flipping my variable. This is a very common thing that you'll see in code too, this like toggling of a variable state value. So it's good to be familiar with it. And so then actually to get the neopixel to turn on. So I'm going to call the library circuit playground, which has a method that is set pixel color. And for this, I need to give it 4 things. I need to tell it which neopixel I'm talking about, and then the RGB, the red, green, and blue values for the pixel. Because as we've seen, these LEDs are cool because they're actually 3 LEDs each, and you can change the color to mix whatever color you want. And these are numbered 0, 1, 2, 3, 4, etc., all the way to 9. In coding, we often start with 0 as the first index location. So there's 10 neopixels, but they're numbered 0 to 9. It's just something we have to deal with. It's not great, but we have to deal with it. So I'm going to say 9, 8, 7. 7's the one right next to this button, so that's the one I want to work with. And let's just give it some values here. And these neopixels are extremely bright. So if I went up to 255 on all of them, right, it's 8-bit color just like you'd use in Photoshop. It would be extremely bright. I don't need to go that high to see that the pixel's on. So that will give me a red, green, and blue. So that's going to give me a mostly cyanish kind of color, I think. Okay. And then to turn it off, I'm going to say circuit playground set pixel color. Same one, but 0, 0, 0. So it has no color. All right, that's good. Let's try that. Let's see what happens. We've gotten far enough, I think. And we got this problem again, so I'm going to double click. Try again. Great, okay. So now if we click this button, okay, so that's weird. So I'm clicking it and it came on, right? But it's not, oh, there, now it's off. Now it was on, oh, but then it went off. So, it's kind of working, but it's not working well. So let's, again, use our serial prints to see what's going on. And to do this, I'm going to comment out these ones, and this is something I will commonly do in code when I'm debugging stuff, because there might be an occasion where I want to put these lines back in really quickly, but right now I know from our last demo that they're constantly spitting out data, which is going to interfere with my ability to see this data, so I'm just going to temporarily turn them off with the backslashes to make them comments. And then down here, it's not giving me the state that I think it's giving me. So I want to see when I'm pressing this button, let's print the value of neo state. So I'm not using quotes here. I'm just saying neo state. So that's a variable. So anytime I have the button depressed, it's going to print neo state, and then it's going to go into that if, and either turn the LED on or off. All right, and we'll open up the serial monitor. There we go. And so nothing. That's what I would expect because I'm only printing when the button's clicked. And so now I'm going to click the button. Whoa. I'm getting 101010 immediate, like right after. So that I forgot the ln part, which would give me the carriage return, but this is useful enough. So even if I try to just click that button once, it's giving me this huge string of zeros and ones, right? Because again, this loop is happening thousands of times a second. And so it's, when I push that button down, it's like, okay, neostate is 0, toggle it. But before I can even release that button again, it's reading this, 10 or 12 times. And it's like, okay, yep, it's still pushed. So neostate is this, so we're going to toggle it. And then what? It's 1 now, and we're going to toggle it back to 0. Now it's 0, and it's back to 1. And now it's 1, and it's back to 0. And it's doing that over and over and over, even in that instant that we're just pressing the button. So we need to slow it down. And we call this debouncing, right? We're getting information from our sensor, which is the button, too quickly for the human operator to deal with. The Arduino is faster than we are. So a sort of brute force simple thing I can do is just add a delay. So if the button is pressed, it's going to do all this stuff, and then when it's done doing its first toggle, I'm going to delay 1000. And that delay 1000 is saying pause the programming here for 100 milliseconds. 1000 milliseconds is a full second, is 1 second. So 100 is a tenth of a second. So that's not a lot of time, but it might be enough for me, the human, to push the button once, as it were. So let's see what that does, and I'm going to add my ln here so that this is a little more clear. Okay, great. Let me go back here, clear this. And now I'm going to push the button once. I got a 0, 1. A 0, 1 again. Okay. Off. On. So even that delay, I'm able to do it, but I have to be very quick. Because if it takes me more than 1/10 of a second to push that button, if I hold that button at all, you'll see it start blinking, right? Because then it's doing the exact same thing that it was doing before. We just couldn't see it what was really happening because it was going so fast, right? But now we can, that it is just toggling this as we're telling it to do, right? From 0 to 1 to 0 to 1 to 0 to 1, as long as we're holding that button. So, if I'm very fast with pushing this, it may work, but as you can see, that's inconsistent. That's not a great user experience for that button on that light. So we can do better. What we really want to do is detect when that button is pushed. Then we want to run our code when it first pushed, and then we want to run our code, but then we want to ignore any other future ones that we're getting from that digital read until the state changes, right? So until the status of that button changes from 1 to 0, then we want to detect the 1 again. But if it keeps giving us 1, 1, 1, 1, 1, right, that's not going to be helping us, right? That's the on that we were getting from this one up here, right? If the button is pushed, constantly gives us ons. Okay, so how do we do that? Well, we need a couple more variables. So back up at the top, I'm going to say we want the current state of the button, and we want to compare that to the previous state of the button. And if those are different, if the current state is 1 and the previous state is 0, that's someone pushing the button. That's when we want to run our code. But if the current state is 1 and the previous state is 1, then we've run our code, but the person hasn't picked their finger up off the button yet. That's giving us the false reading. We don't want to run our code in that case, right? So I'm going to call this be current. And I'm going to set both of these to 0, and then I'm going to say be previous. So those are the states of our B button, current and previous. Then back down here, I'm going to change my if a little bit. I don't want that there, actually. I'm going to say here, be current, equals digital read C play write button. So now I'm using this function, digital read, that returns the 0 or 1 based on the voltage on that pin, and I'm storing that in my be current variable, right? So when I'm doing this kind of assignment, as we saw with neostate, like I'm not redeclaring it. I'm not using the int. I only need to do that once. Now I'm storing the result of this function into that be current space. And so now here I'm going to say, okay, if be current, oh my God, sorry, equals 1, and 2 ampersands, if be previous really equals 0, right? So is the state different? Is there a change between the current state in this millisecond versus the previous state of that button a millisecond ago? And that is going to be 0 because that's what I set it to up there. But then after this happens, right, after I run this comparison, instead of doing a delay, I'm just going to say, okay, make be previous. We've done our check this second, or this millisecond. So it's now going to be equal to the current, be current. Okay, so we're saying, okay, read a new state for be current, check, is that new state different from the previous state? Is it equal to 1, and is the previous state 0 for being off, right? Not clicked. So is the button clicked, and was it previously not clicked? Then we're going to do our toggle. When we're done doing that check, okay, previous now equals be current. Then when we go up, get a new current state from reading it. We're going to compare that to our previous. So if this was 1, we read current 1. This is 0 from our init. It's going to run this. Then previous is going to equal 1 because current is 1. So now they're both 1. We read be current again. The person still has their finger on the button. Be current is 1, but now be previous does not equal 0. This gets skipped because both of these things have to be true with this and comparison. This has to be true and this has to be true for this if to happen. That's not the case, so it goes down here. Be previous now equals be current, which is 1. So be previous is still 1. Person takes their finger off the button. We read the current state. Did you read? It's a 0. Be current does not equal 1. It's 0. Be previous does not equal 0. It's 1. Again, this gets skipped. Now be previous equals 0. We come back. Be current does not equal 1. It's 0. But be previous does equal 1. Or it does equal 0. This still doesn't happen because both of them are not true. It's etc. Right? Like you can logically walk through these, which can be very helpful to wrap your head conceptually around what's happening in your if statements. Let's look. Let's see if it's right. All right, I can clear my output. I push the button. The LED comes on. I push the button, and we get the 0 in the serial monitor, right? Because we're printing the neo state before we do the toggle. I push the button again, and again, and again, and nothing happens. Okay, so I've got a bug in my code. This is great. I can show you this. Similar things might happen to you. Logically, I have to look at where I'm putting this line. I mistakenly put it within my if statement, right? So this is actually be previous is going to equal be current only if this is the case. So only on that very first time that I pushed the button was that true. Did this happen? And then be previous is never getting updated again. Be previous is now equal to 1. And it's always going to be 1 for infinity. So that's not the right place for that line. That really goes here. So after my if, and there's a really nice thing with the Arduino IDE, if I put my cursor after a curly brace, it will put a little box around the curly brace that that one connects to, right? So like this one goes to that one, this one goes to that one, this one goes all the way up there. So I want to do this be previous equals current regardless of whether this if statement is true or not, right? So I want to make sure that that's outside of that if. Let's try it again. All right, I click the button, the LED comes on. I click the button again, the LED goes off. I click the button. Now this works very nice. If I click and hold the button, it still comes on only once. I don't get a stream of data from the serial monitor. I can release it and click it again and hold. And again, it's very consistent now with doing an on and off with my clicks. So that's the kind of thing that is ideal for making this toggle button work, right? Because as designers, as coders, we want to make the experience good for the user, right? We don't want the person to think like, I have to click this button in less than a tenth of a second. Like that's absurd from a user experience perspective. So this is what we want to do to turn this LED on and off. Last thing, let's say we want to turn multiple LEDs on and off. Well, that's easy. I can just add another one here. And make sure I'm doing the other ones. Now 7 and 9 will turn on and off. Great. I'm getting to a point though now where this off state, there is something I could do a little bit cleaner with that, rather than sending it each of these pixels the off state individually. I could say turn them all off, right? And I only know that that's an option because of the library, right? If I go look at the reference for the Circuit Playground library, I can look down at my neopixels. There's my set pixel color. But there's also this one, clear pixels, which is going to turn off all pixels. And it doesn't take any arguments. There's no parameters. It doesn't return anything. It's just that. So I can take that and instead of doing those, do this. Let's see what that does. Turn them on, turn them off, turn them on, turn them off. So that's a way of using the library to make the code a little bit cleaner. So in this video, we've looked at how you can use a momentary button that only is giving zeros when it's not pressed and ones when it is pressed. Turn that into a toggle-like button for an LED, and then how we can control multiple LEDs with that, how we can change the color of the neopixels, and then turn all of them off at once.